Yeah, here we are. Hello.
Yeah, hello, German, and hi, everyone. Thanks for joining us today on a Saturday afternoon. I'm Jiaxing from the Google Developer Relations team, and this is German, the organizer of Flutter Singapore. We are really excited for today's session. I think we have speakers from all over the world, right, German?
Yeah, it's really great. I hope to see everyone, but we still have online events. But it really gave us a great opportunity. Today we have speakers from Australia, UK, US, so it should be amazing. And I would like to thank Google Dev Space in Singapore that, again, helped us to organize this event, and especially Jay. Thanks for that. Thanks for having us.
No problem.
And now let's move to our first topic. Hello, guys.
Hey.
So this team is really awesome, and they're based in California, if I'm not wrong.
Correct.
And we are looking for like a very interesting topic, and I'm personally very curious how would it run. So, guys, please go on. Good luck.
Sounds great. Thank you. Colin, Kevin, should we start with the introduction slide deck?
That'd be great, Tyler.
All right.
Over to you, Kevin. You're on the left.
Yeah, that's right. So I'm Kevin, one of the founders of the App Protocol. Been in the computer industry for a long time, and kind of a startup junkie. I love startups, and I love writing code. So looking forward to today.
Hey, everyone. I'm Colin, Constable, Chief Technical Officer at the App Company. I'm really an infrastructure guy who just likes coding. So sort of on the cusp between infrastructure and code. Tyler.
Thank you, Colin. Kevin. Hello, everyone. My name is Tyler McNerney. I actually can't see anyone because I'm sharing my screen, but hopefully I'm visible to everyone else. I'm a technical consultant. That's good. I'm a consultant at the App Company, and I also attend UC Berkeley as a sophomore, and really excited to be here to talk about Flutter and our technology, which is the App Protocol. So let's get started.
So Kevin, why the App Protocol?
All right. Well, so Colin and I, about 6 years ago, were trying to think of something we've been really passionate about, which is allowing people to own and control their own data. And we were trying to figure out how to do that. And we basically had a couple of aha moments along the way. The first one was, typically when people talk about identity or what is known as identity, it tends to be a big bucket of stuff. So you end up with a bunch of information in some kind of a container that you can use to assert your identity, or ask somebody else to attest to your identity on your behalf, and that's claims and that kind of stuff. And we just said, okay, that's crazy. What we need to do is, we just said, ask ourselves a question: what is the simplest possible thing to do to assert an identity? And what we came up with was a string. So the string is our root. And then we said, holy crap, that's something we could actually build and create a protocol around. And we believe that to make this stuff work properly, what needs to happen is for the handshake, or this is very much a protocol with a handshake, needs to exist as a low-level protocol, not something that you build at the application layer, because that's what we have today. And you've got all these islands of things, and they can kind of interoperate with each other, do single sign-on kind of stuff. That wasn't even close to what we wanted to build. So we wanted to build something where there's a protocol that allows you to securely exchange information between two known entities or two known parties. And it's as simple as it can possibly be, but that's what it does. It allows you to do fully encrypted end-to-end exchange of information between two parties that are known to each other as a result of the protocol. So that's where we started. You go on the next slide, Tyler?
Sure.
So just jump in there on the back of that. So we started with writing a protocol, and we had a big decision to make. Was what I'm a protocol guy. I'm a network guy. What language are we going to write a protocol in? And we chose Dart. Why did we choose Dart? Well, because we could write the protocol in Dart and then have it run on a light bulb or a server. It didn't really matter, and that was a joy. It was the only other language that could offer that would be C, and that would be a 5-year project rather than the 6-month project. So we fell in love with Dart first, and then as we realized that nobody actually wanted to program at the low level, if we could abstract things further up the Dart tree and then into the Flutter tree, then we'd have something really exciting. So, Kevin, back to you. Sorry.
Oh, no worries. So, what we build. So, if let's say you wanted to build an end-to-end encrypted app of some sort. So, in the last month or so, I mean, there's 40 million downloads of Signal in 1 week, and this is in reaction to the privacy or the terms and conditions change from Facebook with regard to WhatsApp. And so, so it looks like people are liking things like end-to-end encrypted stuff. And let's say you wanted to build something that was end-to-end encrypted. So again, you could either do that at the application layer, which is a lot of work, and it's really hard. So that's one way to do it. The other way to do it is to use a framework like the app protocol for building. And what we built is a framework for building end-to-end encrypted apps. And so they're different. They're actually peer-to-peer. And so information again goes between two people. And that gives rise to a couple of interesting things. So one is it's a polymorphic protocol, or the implementation is polymorphic, which means that I can give different information to different people. So because I know who's asking the question, as Colin will tell you, this is the first time you actually have an exchange where you know who the other party is before you have to answer. And so the way that the encryption works is that the answer is uniquely encrypted for the recipient. So if I send something from Alice to Bob, then Bob is the only person on the planet that can decrypt that, whatever I sent to him. It could be a picture, a message, a recipe. It could be anything at all. So and that we organize that around a thing called a persona, so you can make it easy for people to manage this information. And that is where the shared libraries and data comes in. So one of the things we love about Flutter is the ability to create libraries that people can really easily use to build an app with. And we'll show you one of those today. Can you do this, Colin?
I'll do the bottom bit because I'm the infrastructure guy. So at the bottom, we've got a TCP/IP protocol using TLS 1.2. As I said, all of that's all written in pure Dart. What we haven't mentioned yet is that all of this is open source, so you can look at our GitHub repo and our PubDev repo, and you can see all this stuff. You can see exactly how we're doing it. We have our own cloud environment, which is running on GCP. And we also have a standalone local environment, and we're working on a cloud development environment as well. So all the infrastructure is actually catered for you. We've written all that code already. You don't have to touch any of it. Unless you find a bug, of course, and then we'd be super excited about having a PR, because we'd love to get more people involved in that side of things.
And so the okay,
He's going to go back a bit, Tyler.
Go back, sure.
Okay, this is fine.
It's fine. Okay, I'll go back.
So on this slide, on the previous slide, you'll notice that there's a bunch of Flutter libraries and widget libraries, as well as a bunch of base level services that are all wrapped into an SDK. Everything is completely open source. Everything we do is open source. We even have open source apps, which is kind of fun. And then, so basically, again, so this is, I said this before, but essentially apps are different with the app protocol. So an app in the future would be a combination of my data that I'm creating and other data that people are sharing with me. And again, the sharing is done end-to-end encrypted. And the protocol and the reference implementation allows for data caching that's under control of the owner. So I can, on my phone, have chat messages where I'm combining my messages and somebody else's messages. The messages that are shared with me are encrypted just for me, and vice versa. It's cached on my phone, so it works offline, and it's all local. We're currently using a database called Hive, Flutter Hive, and which is an in-memory database on your phone. It's encrypted at rest, and then we add the PKI and some other encryption tricks from Colin for managing the encryption process, especially for doing like many-to-many encryption, which is always a great deal of fun. But anyway, so the apps of the future combine data together from different people onto your phone, and it's under the owner's control. So Alice could say, I'm going to take my messages away from Bob, and they will disappear from Bob's phone, and vice versa. So Alice is controlling what Bob sees, Bob is controlling what Alice sees, and that's what we think future of apps looks like. And so it's cached, it's available offline, and because it's in-memory database, it's really fast. It's a very snappy performance. You're not going off to a cloud server to get data. You're actually, after you do that, then you actually are storing it in cache. And everything is peer-to-peer, so you don't need to have a back-end server for an app anymore, which also allows one other thing which is interesting, which is apps are able to access potentially all the data that you want to share with them, because it's your data on your phone, and your apps can use whatever data of yours that you want. So apps become kind of a lens onto your data and not have a hard-coded relationship or between, let's say, a back-end data model and a front-end data model. The information exchange is via a protocol, which makes it easier to interoperate between apps with data. Okay.
So as we said, we're all open source. You can see everything. You don't have to, as a developer, you don't have to worry about the back end. This leads right to surveillance-free applications. Nobody's surveilling you because there's no place to surveil and everything's encrypted anyway. And as you'll see from Tyler, very rapid development cycles. So you can reuse all the components we've written, and we share as much as we can. So maybe Tyler, you can show us this in action.
Sounds great. Thank you so much, Kevin and Colin. So just a fair warning, I am doing a lot of processes on my laptop, so the demonstration will be a little bit slow, but let's pull through nonetheless. So I currently have the Hello World application running on this Android emulator. The Hello World application being the most basic beginner-friendly application or demo app that we've provided for developers who are trying out the app protocol as well as Flutter for the first time. So I currently have the complete version running, and I'll just go through a quick demonstration of this app before we dive into the incomplete version, and I'll just illustrate how easy it is to code with Flutter and Dart to make a beautiful application. So right now I have a testable @sign, and @sign is basically your account on that protocol. I currently have Barbara, but you can really choose any one of these @signs. And let's go ahead and log into Barbara's secondary server. So it's going to take a little bit to authenticate properly, but once you do authenticate successfully, in the console you should see an auth success message appear. So the Hello World application is relatively simple. You can basically add key value pairs to Barbara's secondary server. So I'm going to go ahead and do that. Since this is a Hello World app, let's go ahead and put hello as the key and world as the value. I'm going to go ahead and update Barbara's secondary server. And once I scan Barbara's secondary server, I'll see the hello key appear in the drop-down menu. And once I look up the value corresponding to hello, I get world. And if I were to hot restart this, you will notice that this data does indeed persist across Barbara's secondary server. So let's take a closer look at the code that is doing this. And for the sake of giving a better demonstration, I think I will go ahead and stop this process and open up the incomplete version of this application. So just to give a little bit of context into what this application is doing, a lot of the components that you saw in the application was Flutter. A lot of these you might recognize, like the list tile widget, as well as the flat button widget. All of these are just native Flutter widgets and are very easy and intuitive to use. And you can see from top to bottom how those Flutter widgets are incorporated into this application. Let's take a look at the dependencies really quickly. So you have some of your traditional Flutter dependencies. And the 3 dependencies that are at protocol related are at client mobile, at server status, and at demo data. And each of these essentially allow you to use a lot of pre-built at protocol verbs and methods to perform tasks like authentication and data persistence with relative ease. So I'm going to go ahead and start off with the login method. And for the sake of time, I'll go a little bit quickly. But as you might have noticed in the introductory screen, what this login method does is it takes in an @ once again, your account on the app protocol, and it authenticates into the microserver associated with an @. So I'm going to just write a couple lines of code to accomplish this. And on a side note, the most important object that we have in this file is called the server demo service variable. And this is essentially a singleton of the service file that we've provided in this Hello World application. And the service file has all sorts of app protocol methods and verbs built in for you so that you can use a lot of these methods very easily. So let's go ahead and get started. Assuming that the @ that was passed in is not null, I'm going to want to call the method called onboard, which has an optional argument called @, and inside of this, I want to pass in the @ variable, which we've defined at the very top of this class right here. Assuming that we onboard successfully, I want to navigate to the next page. And the way that we do that is pretty simple. This is a pretty common method that's used in most Flutter apps, which is navigator.pushReplacementName. It takes in a builder context, which we can just pass in as the context. And for the route name, which we've already predefined in the main.dart file, I'm just going to pass in the name associated with the home screen. That's really all that there is to it. But the way that the app protocol works, you can't actually authenticate into the @ the first time. And the reason being, the way that the app protocol works, we use the keychain manager to basically look for the keys that you need to successfully authenticate into an @ secondary server. But the first time you onboard, those keys are not going to be in the keychain manager. So instead, we want to call a different onboarding method to actually embed those keys associated with an @ into the emulator's keychain. Assuming that an exception is thrown, we're going to want to call a different method. And this method is called authenticate. And this takes in a couple of arguments, namely the @ as well as a JSON data string, which we've defined at the very top of this login method. And this JSON data basically just encrypts the keys associated with a particular @. And I'm just going to pass in the JSON data object there. And we also need a decrypt key so that we can actually decrypt this JSON data. And for this, I'm going to call the @demo-data library and call the AES key map and pass in the @ as the key for that map. Let's just end these with a semicolon. And this is the most complicated methods in the app protocol, but this is essentially all you need to successfully authenticate. Although let's not forget that I'm just going to copy this right here. We want to navigate to the home screen, assuming we authenticate in this fashion. This is the entirety of the login method. And once you write these couple lines of code, you will have successfully authenticated into Barbara's secondary server. And from there, you can use a bunch of app protocol verbs like update, scan, and lookup to manipulate key value pairs in Barbara's secondary server. So let's go ahead and write down these to-dos. And just once again, we're currently on the homescreen.dart file right now, and this is exactly what you see on this emulator window, where if you go from top to bottom, you'll notice a lot of the corresponding components, like the list tile with the update text you can see right here. Scrolling a bit down, you're going to find the scan list tile right here. And all the way to the bottom, we have the lookup list tile right over here. So let's try to replicate what we did over here in the code. Namely, we want to be able to take in a key value pair and assign it and add it to Barbara's secondary server. And once we have it added to the secondary server, we want to be able to scan it and get a list of keys from the secondary server, select one of those keys, and then look up the value corresponding to it. And in fact, that is a relatively complicated process. And if you weren't using the app protocol, this procedure could take many lines of code to accomplish. But let's try to demonstrate how we can do this with just a couple lines of code. So update, we want to add a key value pair to Barbara's secondary server. And the way to do that is let's first initialize an add_key object. Following this, once we have this add_key object, there are a number of attributes associated with it that we can populate to our advantage. So it has a key attribute, and we want to pass the key private variable to it. And just to demonstrate what each of these variables mean, key and value represent the key value pair that's passed into the update list tile. The lookup key is the key that we select from the drop-down menu that was in the scan list tile. And the scan items list is what's passed into this drop-down menu item once we retrieve the list of keys after calling the scan verb. OK, so scrolling all the way back here, we want to assign the key attribute for the add_key object. And once we do that, we also want to identify whom we're sharing this data with. So for the sake of this Hello World application, we're just going to simply assign it or share it with ourselves. But the power and beauty of that protocol is that you can really pass in any @ that you'd like. And you're guaranteed that this piece of data gets shared only with that person you identify here. In fact, not even the company can decrypt what's shared between two @. And after this, there's really just one line of code left to update Barbara's secondary service. And we're going to want to call the service.dart object one more time. And this file is just called @client_service. And we want to call the put verb. And this takes in an @key, which we've identified earlier, as well as a value. Okay. Let's keep on going since we're running a little bit out of time. Scan essentially scans Barbara's secondary server to get the list of keys. To do this, let's first initialize the list object, call it response, and let's assign it to the following verb, get@keys. And this takes in a shared by optional argument, and we want to pass in the @ here. So assuming that this response actually has a bunch of @keys inside of it, we want to basically strip away the @key object and just return a key instead. And let me do this correctly. There we go. OK, so I'm going to make a new list, and this time it houses strings. Let's call it the scan list. And we want to set this to the result of mapping this response list. Over here, let's just call the arrow function. And we just want to pull the key attribute, as we did up here, from this @key object. And let's make sure to convert this to a list. Assuming we do this successfully, we want to call setState, our best friend in Flutter. And let's just set scan items, which is once again the variable we defined at the very top of this class. Let's set scan items to the scan list. And that's really all we need for scan. The final verb lookup will take in a lookup key and spit out the corresponding value. And let's go ahead and do that. So once again, we want to make a @key object exactly the same way that we did for the update verb. We want to pass in the lookup key to this @key object. And we also want to identify with whom this @key object was shared with. Assuming we do that correctly, let's identify another string and call the get verb on the service object. And this takes in an @key object. Let's just pass in lookup here. Okay. And so assuming that the response is not equal to null, we want to call setState one more time. And we want to assign the lookup value, which is another variable that we've defined. And it's basically this variable right over here. We want to set that equal to the response. And that is all we need. So we've implemented a bunch of very complicated tasks like authentication and data persistence with really just a few lines of code for each verb that we identified in this project. And that is really only possible or very easy to accomplish with Flutter as our UI and the app protocol as your automatic backend service. So this demonstration is all fine and dandy, but you may be wondering, well, what more can I do with the app protocol? This is just the Hello World application. So Colin has the @chats demo application running on his very own device, and he will demonstrate how you can use the app protocol to accomplish one-to-one messaging. So it's pretty exciting. Colin, are you good to go?
I think so.
All
see
righty.
You can see my screen, I guess. That's the...
Yeah. I
Yeah,
believe
you
we can see it.
can. All right. That's good. So essentially, there is a Flutter widget that you can use. It's called what is it called now, Tyler? It's just a chat widget? I can't remember. Sarika put it on, who I know is listening.
That's correct. In fact, let me show you real quick. So some of you guys may be wondering, well, yeah, how exactly can you implement a chatting application with the app protocol? So I will just go ahead and open the project associated with this chat application. And the answer, as I like to say, is really just one line of code. So here we have the incomplete version of the chatting application. And it has a couple of screens. And you're going to notice a lot of similarities here. Like, oh, well, this is the exact same authentication method that we wrote for the Hello World application. And if we move on to this third screen Dart file, you're going to notice that there is, a scaffold widget, and it has a body, but we've currently set it only to a container. But we want to have a chat screen here, and implementing a chat screen with just one widget may sound like a ridiculous task, but we have an app protocol library called @chatflutter. And what this does is it takes in a @ and another @ that you want to chat with. And based on that information, it makes a chat screen widget like that. So to implement a chat screen or a messaging application with that protocol, you need to just call the chat screen widget from the @chatflutter library. And it's as easy as that, just one line of code. So with that said, why don't we move on to the demonstration? Yeah.
And a huge shout out to Sarika who put that together. Pretty amazing stuff. So I have here a Android machine on the right. You can see this here, and on the left, an iPhone. I prove it's an iPhone because you can see it there. And we're going to have Alice and Bob talk to each other. So we're going to say I'm going to log in as Alice on there. We'll fire up the application on the Android. And Alice wants to chat with Bob. So you can see in the background, all those to and from @ are being set up. And I want to go to a chat window. And over here, Bob is going to log in. And Bob wants to talk to Alice. And we can navigate to the chat window. All of this code, by the way, is available to you. You can get to see this. And let's see whether the demo gods are with us. And we'll see. Yeah, demo gods. Look at that. I see demo gods on both screens. Yay. So you wouldn't believe how much technology there is going on here. So I am running these are two physical devices. So just to prove that they are two physical devices, there's the one app and there's the other one up. So these are real devices. You can see they spun around as soon as I move them around. And I'm sharing my screen, and then Tyler's sharing the screen there. So that is that single line of code working in action. So hopefully you guys saw that. And there was a question I noticed in chat, which we should probably answer. which is, how does all this work if there's no servers? Well, the fact is there is a server, and the server is a microservice, and it's dedicated just for the @sign. So in this case, Bob and Alice have their own microserver, and that's run in the cloud. It's actually run in GCP. And it can run anywhere, and it can be owned by anyone. We're just running them at the moment because there's nobody else to run them. But if you want to run your own, you can definitely run your own. And you can see how to do that when you go to @sign.dev and see how the developer environment is put together. You'll be able to see it all. Again, all that code's available to look at. So that microservice is written. Microservice is written in pure Dart. It runs in a Docker container, and it has the grand sum of 4 megabytes of memory. So this really is a microservice. So that enables you to store encrypted data for somebody else, and so they can pick it up when maybe your phone's offline, or maybe you've switched off the internet, or maybe you're just not available for the moment. So that's where things can be stored. The secret is the keys are always on either party's mobile devices. And the key that Kevin and I were waiting for, and we couldn't do this, why we couldn't do this 6 years ago, is because phones back then were just not powerful enough to create the sort of crypto keys that we needed. So yeah, that's how that works. So if you want to get started, if you actually want to run all this stuff yourself, you can go to @sign.dev. You can look at our @sign Foundation GitHub repo. You can see everything there. Probably the most active part of the company at the moment is our Discord community. If you scan that QR code, you can come join and just say hi. That would be awesome. Back to you, Tyler.
Sounds great. Thank you so much, Colin. And I know we are at the 30-minute mark, so just to reiterate, all of our information is up on our dev site, so please refer to @sign.dev to find all of our demo apps and just about anything you need to start your journey with the app protocol. The QR code for the Discord community is there, and if possible, if we could put it in chat, that'd also be great. But otherwise, thank you so much for having us. We love Flutter, and I've personally made a lot of Flutter applications before with the app protocol. So we're really happy and glad to be here. But just to celebrate the 30 Days of Flutter challenge that has been going on, the app company is giving away 100 free Flutter courses to those who join our Discord community. So we really hope to see you guys there. I think that's everything.
Okay, thank you, guys. It's looks pretty interesting, and I believe there are a couple of questions. Unfortunately, Colin, you already broken our flow. You started answering them. And as a reminder, guys, if you have any questions, please drop it during presentation, because there are some lags when we can see this. So you have already answered on question about server. I believe there might be a few more, but there's one more question. What's your opinion about junky animations on low-tier devices? I'm just.
I'm going to let Tyler answer that one. That's a great one.
But I don't think I heard that correctly. Junky animation?
Janky animations.
I must be. I'm not quite sure if I get the reference.
So I think is it on low powered machines? Animations sort of get pretty sucky. Is that?
I see.
I'm pretty sure that's what it means.
Fair enough. I am running a 2016 MacBook, so if that counts, then sure. Sounds great.
Okay. One more question. Actually, it's also what I wanted to ask. Thanks.
Yeah.
So basically, if the user is not available, I'm offline, Anand offline, how would we find our data?
Yeah, that's that's a fantastic question, and that's one of the reasons why every @sign has its own microservice. And essentially, it's your sort of your @sign guardian. It will actually answer those questions if it can, and if it can't, then it will store that question. And when you come back online, you'll get what we call a notification, and then you can deal with the notifications. So again, all of that code's available. You can see it. Probably the best thing to look at for notifications, there's a a full-scale app that's on both stores, iOS and Android, called Atmosphere, and it's for sending a encrypted file from person to person. And one of the things it does is actually notifies you that somebody sent you a file, so you can actually see how that verb works and how those methods work. And if you're not there, then it will get stored, and next time you connect, your secondary server will store it, and then it'll give you the notification. It's actually two bits are really tough to do. One is notifications, and the other one is synchronization. And obviously, all that stuff's abstracted away for you.
Okay. Actually, I have a follow-up question. Looks like you are saving data and you are hosting these microservices. Who will pay for backend? So basically,
how do we make money? That's a good question. Kevin, how do we make money?
Well, so we're I start off saying, so we were crazy enough to say we're going to write a server in Dart. So we actually have a cloud server that's purely written in Dart. So we start with that, and it's super efficient. So it runs in literally 4 megabytes of RAM, not gigabytes, 4 megabytes of RAM. And so first of all, we drive the cost down to as low as possible. That's the first answer. And the second is we pay for it. So every person gets a free microservice in the cloud running on GCP that we can't look inside. We can't see anything, and that's provably true. So we can prove that we can't see your data
unless it's public.
Unless it's public, and then it's public. And then so from there, and if you want to run your own. If somebody wants, if telco or somebody wants to run them, great. That would just save us money. But right now we're running them, and we built it to scale to 50 billion endpoints, at least from the directory side. So it's built for internet scale for sure. And then the other thing that we do, so most of the data is actually, it starts on your phone, so it's actually literally stored on your phone, and but it's also it's synchronized to this microservice in the cloud that can respond on your behalf if you're offline or whatever. And there's an event model so that data changes can propagate between devices, between the person sharing something, and the recipient of that information could all be monitoring those notifications. So it's a protocol that allows you the exchange of information, including notifications of data change events. So that's but we're doing that the way we make money. We actually are just selling @signs. So you can get @signs for free, and most people do. So we're assuming that almost everybody will get a free @sign, but some people want to have their own personal brand. So I don't know, at Kim Kardashian or at whoever will want to have their own personal brand. So they'll buy an @sign, and it's kind of like a domain name, but it's a single @sign for you or your company or whatever, and that. Over time, will hopefully start to replace all the individual identifiers on Instagram and Twitter and TikTok and so on, and have a single name for your stuff. And so ours is @sign company, for example, on Twitter. So it starts to give you your own personal unique identifier. And so there's enough people will pay for it, we believe, that will allow us to provide those services for free. And that's it. And the best news is, if you're a developer and somebody buys an @sign because of the app that you build, you get a 20% commission on that @sign. So it gives app developers a new revenue stream that didn't exist before. So, and that's 20%. Of $100 @sign is $20 per new person. That's not chump change. So we think that's pretty interesting too. So we're the only development platform that actually pays you money that I know of. So that's kind of fun.
Okay, I like how you switch the topic from why we don't pay for your service and how you pay back.
Yeah.
Actually, I have a bunch of questions, but for sake of time, I will take maybe this one. It's not fully question, so it's coming from Deepak that looks like it's great to have some Dart protocol. And I had a related question. Looks like you started a while ago to work on that, and basically Dart before Flutter, maybe like a few years ago, wasn't so popular. And it looks like it was a pretty crazy decision. How did you decide to start? So our next topic, Brett will cover something from that, but how did you do it?
So this is the power of the Dart and the Flutter community. So it was me that made the crazy decision. So it was on me. But I was advising another company, and they had a really cool idea about using mobile devices and extending private branch exchanges, so extending corporate phones out to mobile phones. And their CTO said, what we should use is this Dart stuff because it's really cool. I'm like, well, how cool is it? And he said, well, you should see how cool it is, because I've been working with the Flutter community in New York City. He lives in New York City. It's really super vibrant, and you should take a look. So like, okay, I'll take a look. So when Kevin and I were sitting down, we said, like, we could write this other stuff in C, but it's going to take forever. But like, let's just start with Dart, because Richard said it's a really cool thing. And Richard's a trustworthy guy, so we trust Richard. And so we started writing some code, which was really just demo code. And it slowly got out of hand, because every time we turned into something that was difficult, like, an in-memory database is difficult. And the HiveDB devs didn't have everything together back then. But we reached out to them and said, what about this? What about that? And they were awesome. I mean, just incredibly cool. And then we needed some crypto libraries, and the Pointy Castle guys were out there, and they were cool. So it was really complete. It was the community that pulled us in. I mean, we couldn't have done any of this without the Dart and Flutter community. I mean, this wouldn't have happened.
Yeah, Colin found a bug in the Pointy Castle stuff too. Both a double unicorn bug. So we support the full Unicode character set, and so you can have emojis. Your @ can be emojis if you want, or Chinese characters or whatever. And at the moment you can only register with Latin and emojis, but the underlying code supports the full character set. And Colin found a bug for if you put a double emoji onto Pointy Castle, it'll throw an error. And so
it was the UTF-8 to UTF-7 converter, because HiveDB uses as its key, it uses UTF-7 for all sorts of good reasons. So it meant that we had to convert a UTF-8 to a UTF-7, and that library has been around for a decade or two. But obviously nobody had ever tried to convert a double unicorn into UTF-7, because when they did, the whole thing fell over. And not only was the problem in the Dart code, the problem was in the convert code in Dart, but that had been sort of cribbed from a library that was written in JavaScript, I don't know, a decade before. And it was still in that one as well. So we got it fixed in the Dart library, and then we had to get it fixed in the JavaScript library that it was based on. So I did that makes me so happy when the community does that sort of stuff.
For me, German, the test has always been, every time we had a discussion on what to write this stuff in, I'm like, light bulb tests. So I want to be able to run my code in a light bulb or a thermostat or a wearable or a whatever. So it's got to be compilable and efficient to run on anything you could imagine. So Dart was the technically the best answer for running in a light bulb. That's my test.
And nice clean binaries. I mean, really nice clean binaries. And it's going to get better with the null safety stuff. Those binaries are going to get tighter and tighter. So it was a mad decision, but I think it was the right mad decision, as it turns out.
Thank you. I believe there are tons of other questions, but probably I will keep it for the next time. I have questions about Rust and so on. Just very, very interesting.
Come join us on Discord. And
okay.
We have hangout sessions all the time. You can come and hang out with us and talk about the philosophy of code.
I will try to build Hello World application. Thanks for joining us. It was really cool. I wish you good luck.
Thank you, sir.
Thank you,
so much.
everybody.
Bye-bye.
Appreciate your time.
Hello.
Hello, Brett.
How are you, German?
I'm great. I'm really great, and it's still midday in Singapore, so it's very nice. And how are you?
Not too bad. Enjoying the late afternoon here in Sydney, and looking forward to introducing the Flutter developers up your way to, a different environment.
So looks like today we have really, much in topics. Because before we have just finished with Dart for backend. I think it was almost the first company, maybe at least only Aqueduct that I heard of that uses Dart for backend. So if you can talk more about it, it will be great. So good luck, you too.
Thank you very much, German. So, hello everyone. I'm Brett Morgan. I work on the Flutter and Dart developer relations team. I'm based here in Sydney, and I'm here this afternoon to talk to you, or this morning, depending on your time zone, about using Dart in a bunch of different places. I'm going to be showing you some Cloud Run. I'm going to be showing you the gRPC library as a way of creating an API and then using that from Flutter. So, looks like I need to click on the window. So yes, using Dart on the server and the client. So what am I going to cover today? I'm going to talk about running Dart on the server, have a look at Google's Cloud Run service, introduce you to the concept of gRPC as a way of easily building APIs, and then I'm going to show you how to use gRPC in Flutter easily. What do I do as a day job, and how does it play into this? Well, there's this little service that you may have heard of called Dartpad. It allows you to type some Flutter code or some Dart code, press run, and have it work in your browser. I'm actually responsible for the compilation backend of this service, and it's, strangely enough, all Dart, and as of a couple of months ago, it all runs on Cloud Run. Before that, it used to run on App Engine Flex. So, how do you get started with Dart on the server? So the easiest way to get started with Dart on a server is to activate a package called Stagehand. And Stagehand is a way of generating templated Dart packages, or be it a command line application or a server application, that sort of thing. We'll make a directory and then have Stagehand build us an application. So let's just escape out for a second and drag in a window. You'll get some code that looks roughly like this. This is not quite exactly what you get right now. This is sort of Stagehand from the future. This is me making it null safe. I'm not sure if there's any changes here on this specific screen, but this is what it looks like. And to run it locally, all you have to do, if I can type straight, server.dart. That will turn around and start serving on localhost. But let's take it further. So back to presenting. I just showed you running on the local host. We can turn around and Dockerize. So we can turn around and build it using Docker and then run it. So actually, no, let's escape. I can't get out of my own browser window. So Docker build. So we can turn around and build this server. Now I have made a slight change to I've actually made a bunch of changes to the normal package. But one of the things that I need to add to the template is the stock standard Docker file that we have with Google Dart. Now, this one I'm, as you probably guessed, using null soap code, so I'm using the 212 beta branch. But apart from that, it's the stock standard Docker file. And here we've built things. And if I do Docker run and bind port 8080, we can see we're again serving at port 8080. And I can come over here and do localhost 8080 foo. We get a request for foo. So this is all good and all, but how does this help us with going further? Well, let's talk about Cloud Run. What is Cloud Run? Cloud Run is a way of taking a Dockerized server application and running it in a little virtual server in the cloud. And what do we have to do? Well, we have to log in. So firstly, create yourself a Google account, create a project, then authorize your local command line using gcloud auth login. That will send you into a web browser where you can say, yes, please allow this command line to make changes to my project. Set your project. My one's going to be Bob's Burgers. We'll see this off in a bunch of different places. And finally, we can turn around and ask it to build. So I'll just, for various reasons, I need to actually run up a second shell to kill the Docker in the first shell. Now, what was that command again? Gcloud builds. So what we're doing is we're submitting a build to a cloud build, and it's going to take a snapshot of the current directory, and we're going to tag it. GCR is the Google Container Runtime repositories, and Bob's Burgers is my project, and Dart Server is the name of the actual thing that we're building. So I do that, and then I can drag in yet another window. And we can see, yes, here's all the tests I was doing while building this deck. We can see that we've kicked off a build. We have a look in here. We'll see that this is streaming and matches pretty much identically here. So what we've got is we've pushed a bunch of code up to a server. That's now building in the server farm. And once that actually completes, we'll then be able to take that that image. Okay, it looks like it's completed. There we go. So we can now look at the container registry under Dart Server. Remember, I pushed it to GCR, Bob's Burgers, Dart Server, and this is the latest one. And what you can do, though I won't in this instance, is you can turn around and deploy to Cloud Run. This allows you to create a new endpoint, but to make sure the rest of my code works, I'm actually going to stick with a pre-built Cloud Run endpoint, just so that my DNS names all line up. So I can come over here and go to revisions and go edit and deploy a new revision. Let's just make this window a bit bigger. And as you can see here, again, this is that GCR URL that I pushed to originally to start building all of this. The container is expecting connection on port 8080. I'm giving myself some room to play with, 5-minute timeout, 80 requests, and importantly for those on a budget, it will actually support scaling to 0. This is different to, say, App Engine Flex, where you have to have a minimum number of machines serving to actually respond to requests. So we can turn around and kick off deploy, and this will then turn off and start taking that Docker image, instantiating a VM, and actually running some stuff. Anyway, back to our code. So talk through this, configure a project, push to it, and that actually creates your service that in the cloud. So having a service in the cloud is great and all, but it'd be nice to actually talk to it. And one of the downsides of all the various different APIs is you wind up having to build client libraries and all that sort of thing. So I'd like to introduce gRPC as a way of easily and quickly building APIs without the need to manually spin a wrapper for random JSON blobs. Okay, one of the things you need to do inside of Cloud Run is enable HTTP 2 connections, because gRPC relies on HTTP 2. This enables bidirectional streams, which we'll get to. This is something we released reasonably recently on Google Cloud. It also enables things like WebSockets. So for those of you living inside of web browsers, HTTP 2 isn't that easy to use, but WebSockets definitely are. So if you're looking to build real-time reactive websites, be it chat clients or whatever it is, something that actually interacts with the user, you can now use Google Cloud with Cloud Run to be able to empower those sorts of experiences. You just have to enable this preview connection style. Okay, so let's have a look at implementing different styles of APIs. So the first one we're going to start with is good old REST style. So let's drag in yet another window. Where is it? You'll notice they're all different colors. I do this so that I can remember which one's which. So let's just hide a few things. We'll come back to them later. Okay, so gRPC is a way of defining an API. So it starts off, you're looking at a protocol definition file. The syntax is Proto3. Yes, there were Proto2 and Proto1 back in the day. Many mistakes were made, many lessons were learned. Proto3 is the one that we suggest everyone uses these days. And it contains a bunch of fixes for prior architectural misdecisions. Okay, so how do you start defining a protocol inside of gRPC? Well, the first thing you start with are messages. So in this case, what we're modeling is, for those of you who've used Flutter, you've seen the Flutter counter app. I'm going one step up and having multiple counters. So we're going to create an application that has the ability to create counters, add to those counters, decrement those counters, and if they decrement to 0, they go away. So this service effectively is a small part of, say, a Redis server where you have the ability to increment and decrement fields in memory. That's effectively what we're going to build. So the first thing we need is for this server to say, here's a counter, it's named foo, it has a count of 3. Okay, the next thing we need to be able to do is increment and decrement a named counter. Seems reasonable. And the last thing we want to do is turn around and, when someone increments or decrements a counter, give them the list of the current set of counters and their current counts. So this is great. We've got a bunch of messages that go backwards and forwards, but I thought I was coming here to talk about APIs. Well, to talk about APIs, what we do is we create a service, and a service has an RPC. In this case, we have the ability to increment using the increment message, increment request, and we get the counter's reply. And likewise, we've got the decrement request, and, well, we should generate some code. So this is responsible for generating the client library. Remember earlier I was saying the upside of doing this is that we That's slightly worrying. Yeah. Let's bring this back. And yeah, cool. So what we're going to do, I'm just going to reset a few things to make sure everything's sane. We're going to start taking this forward. So if we look in the directory, what we've done here is product.out out, and this gRPC project is beside the Dart server, which is this. And we've written in lib source generated for the counters. So we can see in here, lib source generated, and we've got these 4 files that are generated. They contain all of our client library information to be able to talk to the server or to create the server that we're going to build now. So let's go ahead and build. So first thing we're going to need is to include those files that we generated plus the gRPC support library. What we're going to do is counter service. This is going to be where we implement our business logic, i.e. we're going to have, well, let's just turn around and build it. Here's the counters. We have a name for a counter and the current count. Now, as previously mentioned, there was the decrement call and there's an increment call and some business logic. If we have the counter, then we increment it. If we don't have the counter, then we create it and set it to 1. Likewise, we have, we're going to return the list of counters in a counter object, the counters reply. And this is entertaining. It's currently warning us saying it's not the right object type. How do we get around this? Well, we mark this whole function as async, and because it takes a future of counters reply. This is not necessary for us right now, but what it comes back to is the fact that you kind of expect when you make a call to an RPC service that it might need to read to disk, it might need to talk to some other servers, and it will come back to you at some point in the future. And in Dart, that's all modeled, thankfully, through futures and streams. So let's start implementing decrement. Likewise, we've got business logic, and we have the return. And what does the actual main server look like? Well, strangely enough, once my editor finishes typing, there's not that much here. We create a server that has the service. We're handling gzip codec and identity codec. And finally, we serve on port 8080. Cool. Let's turn around and push this all. Oh, yeah. Just to confirm, I'm just cleaning up the imports. And here's the command to actually turn around and, as previously, push this all up to Google Cloud. Now that's going to start building. I'm going to let that build because having a server in the cloud doing something is nice and all, but it's much nicer if we can actually look at that code and, use a client library to do something with it. So to turn around and actually build something, let's do the same generation, but actually push it into a Flutter client. So likewise to the Dart server that I was just showing you, I've got another project alongside this one called Flutter client. And let's drag that in. So yes, the sort of grayish one, this one is the gRPC, the red one is the server, the blue one is the client. Now, there's a fair amount of code here, but it's basically a slight adaptation of the Flutter counters application. So I'm not going to go through explaining it very much, but the only thing of note that I'm really going to concentrate on is this change notifier, which I'm using provider to turn around and provide into the rest of the application. could actually run this right now. So let's bring this up. Let's just build for Mac OS. And no, I don't want to enable. Okay. So debug console. So we're launching this on a Mac OS in debug mode. This will take 30 seconds or so, hopefully. And in the meantime, I can see what, oh, that's finished building. The only downside of being a developer is you have to develop multiple things at once. So let's edit and deploy a new revision. Take that off screen. And previously I mentioned that to use gRPC, you need to enable HTTP to connections. So we've done that. Let's deploy the latest version, which is the one we just pushed here. Okay, that's going to give us a gRPC server. Here's the multi-counter app. The idea being we can enter a counter and go create the counter, but, well, it doesn't do anything because, well, nothing's implemented yet. So let's fix that. So the first thing we're going to do is pull in gRPC and the client libraries, and let's start implementing. So for those of you who are using the current stable version, this magical late keyword might look a bit interesting. It's actually an addition to the null-safe version of Dart, which you will all be seeing a whole bunch about really soon now. I'm effectively just living in the future a bit to show off that, you know, interesting new things are happening. Okay, so we've got this counters client. Let's build a constructor. This DNS name, if we have a look in here, we can actually see that DNS name here. So I'm talking directly to the gRPC service in the cloud. I'm using channel credentials secure. The Cloud Run is supplying us a SSL certificate, and we've got a client. Now let's actually turn around and build out the ability to send those messages that I was talking about, gRPC messages. So that sends the increment and decrement message, but we should also deal with the response that comes back with a list of counters. And what we're going to do is create this function, and it's going to clear the counters, go through each of the counters in that response message, and set them in the local state, which is up here, and then notify listeners, which is the change notifier protocol, which will then turn around and call set state under the hood to update our Flutter screens. Okay, let's wrap both of these awaited requests so that we can handle the response. And that should be it. So I can now bring some additional players to bear, and I can turn around and not just run one. I can make my laptop really unhappy by trying to run all three. So as you can see, I'm now compiling up Android, iPhone, and Mac OS. And it's usually not this cramped, but I'm running at a reasonably high or a reasonably large font size to make this legible on fonts on YouTube. So let's see if I can get the debug console, and we can see that we're building out iPhone 8. Mac OS is also, oh, yep, that's building, and Android is also building. So just waiting 30 seconds for the world to build. Let's go back here and make sure, yep, we've got the latest one that's serving. We can have a look in our logs and make sure that we've actually got something here. You can actually see debugging traffic from when I was previously using it. The important line here is the server is listening. It was replaced. Okay. Let's hide some of the noise. So the macOS desktop application has come up. The iOS one has come up. And Android has coming up in the process thereof. Okay, counter name. So I should be able to do hello. Come on. There we go. Flutter. And about now, you should be going, there's something very wrong. And it's about now that I go, that's interesting. That doesn't look right. I've got hello Flutter developers. And if I was to add something else over here, what's going on? Why am I getting this sort of differentiated understanding of state on the server on my 3 screens? And about now, well, firstly, I'll shut down a bunch of things. Let's hide that. Hide that. And I'll come back here and remind you that the RPCs as initially defined was you send an increment or decrement request, and then you get a copy of the state as it is at that point in time. Interesting. This is actually how most APIs work. You basically ping them, they tell you what the current state is, but they don't promise to give you any update of the future. And that's kind of a problem. And that's the traditional problem with a lot of APIs. So, oh yeah, here's my slide giving it away. So what we've just implemented is a REST style. The next one I'm going to show you is the streaming response. And if we have time, I'll show you bidirectional. So let's go ahead and refactor things so that we don't have the problem we were just seeing. Okay. So what do we have to do? What changes do we have to make to actually have state updated on the clients in real time or semi-real time? Well, the first thing we need to do is introduce some new concepts. So I'm going to have a counter request and counters reply. And I'm going to have a null reply. Now, in gRPC, all RPCs have a request and response object. There are ways of saying that this has no actual response as opposed to just this null reply. One of the patterns that I've seen is that you really want to have a named request and response object to every RPC, because at some point you'll want to add something new to either the request or the response. And if you have to change the name of your object, that's a backwards breaking change. Whereas if you have an object and you're just adding attributes to it, that's not backwards breaking. So done that. What we're going to do is introduce a new endpoint service. And the important thing is this keyword here, stream. So what's going to happen is someone's going to connect to the service. They're going to give it counters request, which is currently an empty object, and they're going to get a streaming response. So this is traditionally what people normally do when they first play with something like WebSockets. They basically want to be able to connect to a status thing that tells them, new messages have arrived or update your screen because of whatever, and so on and so forth. So this is effectively the start of a streaming reply service. Okay, what just happened? Oh, yes. Because increment and decrement don't need to respond with anything, because all the status change information is coming over this service request, we can turn around and do that. Okay, time to generate some new API client libraries. So let's do that again. Let's do the server. So somewhere here, I've got a red editor. And as you can see, suddenly everything is upset because I've changed the type of things. So let's hide that window and go forward. A lot happened just there. So the first thing is we drop the this tag, which is mainly there to remind me to type it. But the more important thing is we're no longer responding to the decrement call with anything. We're just returning an empty null reply. Let's do the same for increment. And finally, we need to implement this service that's actually going to be responsible for generating or to updating all the clients to tell them the world has changed. I'm now going to lean on a package called RxDart. RxDart is really neat. It gives us a way to create a stream really effortlessly that we can then turn around and put messages into and have the stream go out. So the class in question is called behavior subject. In this case, it's a behavior subject of count as reply. So what we're going to do is we're going to take that subject, take the stream of it, and that becomes the response to listening to a service. And then we're going to add to both increment and decrement is this chunk of code that turns around and constructs the count as reply as it did before, but it turns around and adds it to the subject. This is how we effectively broadcast it to everyone. There's exactly one subject for the server. Everyone who calls increment or decrement then updates the state in subject, and then that gets passed out to everyone who's currently listening to the service stream. So behavior subject is acting as a broadcast stream. Okay, it's telling me to build again. So let's bring that up. Start building again. And back over here, we go to the next page. Let's update the Flutter side of things. So we've changed the client library. We go to the Flutter window. Remember, Flutter is the blue window. Server side is the red side because it's dangerous. Okay. As you can see, because we've changed the contract of the API, the client library has turned around and broken our code. This is the nice thing about automatically generated client libraries is that you get type safety. So let's turn around and start making some changes. What did we change? Oh, we deleted that line that told me to do things. Next thing we're going to do, just to show you again, we're removing update counters because increment now it returns the null reply, doesn't give us any useful information, which means that update counters are sitting here all lonely. So what we're going to do is we're going to make a call to the service, and then listen basically handles that stream response and uses update counters. And that's the entirety of the change. That's actually finished building. So I need to go back to the cloud run, go to the Dart server, go to revisions. Yep. Edit and deploy a new version. Deploy. And that will take a couple of seconds, during which time I'll dig out my phones. Yep, that's deployed. So I can come back here to Flutter, go all devices, start, and this will take 30 seconds or so to spin up and bring up all the devices. Oops. Should really disable the lock screen when I'm presenting. Okay, so this is launching. Now, I'm cognizant of time. I do have another spin through this that introduces things, but I'm thinking this is probably enough. So I'm kind of curious if there's any questions in the feed while we're waiting for things to compile, or if you want me to, write more code.
Sorry, Brad. I think you stopped sharing.
Okay.
Don't you mind to return?
That's okay. I can bring everything back. I accidentally. Yep. There we go. Yep. Sorry about that, Jermaine. So we've got code. We've got server running. This is the RPC we've got running. This time, when I turn around and come on, wake up. What's going wrong? I don't know. Everything's broken. Let's go have a look in the logs. Increments are going through. Don't know. The joys of debugging live applications. Yeah. So, don't quite know why this is broken. That's hilarious. It worked previously. But as German has just pointed out, I'm out of time. So I'm curious if there are questions. And if there aren't, then I'll show the most important slide in my slide deck. So I didn't get to bidirectional. As I hope most of you know, it's probably March 4th for all of you, but really soon we're going to be doing our quarterly release the new version of Flutter. We encourage you all to come along and see what we're announcing. And with that, thank you.
Hey, Brad. While I give our guests some time for typing their questions, if any, I have a couple of them. So actually, I'm a fan of gRPC, I'm a fan of Dart, and when would you recommend to use Dart for backend?
The primary reason that I have for using Dart on the back end is that it means that I can write the client side and the server side all in one programming language, and I don't have to pay the context switching cost of going, I was writing some Dart today, but now I have to go write some Go code, and my brain is hurting, which I did recently, and it's just all the little differences in programming languages come out to bite you. Whereas if you can use one language everywhere, it means that you have one set of libraries and one set of plugins for your editor and all that sort of thing.
Okay. So it's nice that you mentioned Gore, and I hope Artem, our next speaker, also will touch it. Let's see. But next question, how do you see Dart in backend? Because as far as I remember, I didn't have a chance to check right now, but before, Dart is perfect language for UI, and so how you see it for backend?
Funny story. I remember when JavaScript was considered a client-only language, and somehow magically JavaScript became a server-side language. Dart actually has a fun history with the development team who previously worked on the JavaScript VM, which is of course the basis of Node, and before that they worked on Java. So as a server-side language, it's actually quite useful, especially now that Dart has the head-of-time compilation code that came across from Flutter. So you can do fun things where in your Docker build, you can do a two-stage Docker build where you construct, compile, and ahead of time compile your Dart server, and then put that in a slim Docker image, and thus you wind up with quite a small Docker file that you deploy to, whether it's Cloud Run or I'm sure AWS and Azure have the equivalent of being able to run a Docker server. It's kind of the thing all of us are doing these days. So I find it quite a lot of fun. And my day job supporting Dartpad, it's all about putting Dart inside of Docker, inside of Cloud Run, and serving lots and lots of requests with it. So I'm quite happy with it.
Okay. Thank you very much. And we will move on.
Thank you very much. Thank you for your time.
Hello, Artem.
Hi, German.
How are you?
Yeah, fine. It's a beautiful dawn starting here in UK.
So
a bit early.
Artem is joining us from London. What time is it?
6:26. So yeah.
Right. So Artem is going third, and looks like he had enough time to wake up, I believe. So let's
Say coffee.
Are you ready?
Yeah, sure. Yeah. Let's start from the presentation, I think. So my name is Artem, and currently I'm working at Skyscanner in London as a principal mobile engineer. And in my own time, I'm working on some side projects using Flutter. So I really like Flutter, and I think that it's a future of mobile development. So that's why I'm investing in this language and the framework. And recently I started one of the projects, and it was a bit hard for me to understand all the exceptions handling that Flutter and Dart can provide you actually. And I explored a bit, and I wanted to share some result of my exploration. So actually, let's start from the high level. What is an exception? Exception, actually, I found two kind of definition of this, and I wanted to share it. So first, it's an inability of an operation to fulfill its contract. So just imagine you have some function, get remaining amount, as I can see on my screen, and it actually hits some backend, and the backend returns some amount, some money, and you return the money. And it's fine, right? But if backend is not available, for instance, what then? So contract now function is returning money, but you cannot return money in this case. So what function should return then? Yeah, this is the first thing. And this is like a philosophical question. So because probably you can extend your contract and add some error in the contract. So it could be, for example, either money or error. So yeah, it's fine. But when you should actually bother about this, when you should make this kind of checking this error and reacting to this, should it be in this piece of code or higher upstream? So yeah, all those questions arise when you start thinking about the exceptions. And the second definition, it's exception is unexpected behavior. So if, for example, you 100% rely on some function, right, and then you return some value from this function, but it's not possible, I think, in our as a software developer, you shouldn't rely 100% on any function, right? Because this function can use some dependency on another function that has dependency on another function that can, in the future, something will be changed and it will start, throwing some exceptions. And for you, it's unexpected behavior because you didn't expect it before. And again, so this is this is another thing to think about how can you protect from this. And in different languages, people come up with some different actually conceptions of this. It's more like how you want to design your code. And some languages encourage you to use this or that model of handling the exceptions. So for instance, in Dart, it's the same conception as you can meet in, for example, C++ or Java. So you use try-catch blocks to actually catch. So Dart encourages you to see the only happy path of your function and do not think about exceptions in the first place, right? So it's like you have your main code, happy path, and then you have another block of code where you can take care of exceptions if you want. But if you don't want to do this, you can just silently pass all the exceptions from this block of happy paths to upstream. And in upstream, you can handle them. Not in all languages it looks like this. For example, in Go, you have another conception. So if function can return error, then it should return error, and you should handle this error after you have the result from the function. So your function then will return tuple as a value and error, and you should handle error right after the function and decide what to do with this error. So you can understand what is the error and react somehow. For example, you can pass. You can again rethrow some kind of rethrow the error upstream, but this is very obvious from this code, for example, that I put here. Yeah, I'm sorry, it's not the same how to say business logic in each of the code samples. But I think it gives you the understanding of how it looks like in different languages. And Go encourage you to think about the errors in the first place, and it encourages you to think about errors on the same level of importance as your happy path, actually. And lastly, it's Rust. It's a third way of handling exceptions. So in Rust, if a function can return errors, then it should. And so it's like almost like in the Go, but it returns you some kind of either. So it's either error, it's either value or error. And Rust provides you with some rather fancy way of make some kind of pattern matching. If it is value, then it's value. If it's error, you can make another pattern matching for error handling. Yeah, and again, so here error handling is this has, I think, the same importance as your main flow, as your happy path. So it's different from Dart. But what's good about Dart and Flutter is that you can actually implement both these ways in your code. So if you like, for example, how it's been done in Go, you can do like this. You can just return the tuples from your function, or some object with the value and error inside. Or you can do like Rust does this. So you can return either so result with value or error. So it depends on you and your design on how you want to do this actually. And let's dive into the Darts and Flutter exception handling. So I will switch to the code, and we will talk about the different types of exceptions there. So for instance, in Dart, you can catch exceptions in synchronous code, and in asynchronous code, that is very good. And actually, you can. We will talk about exceptions in stream listeners and some. I will talk about run zone. Actually, it's a bit new conception. I mean, new from the other languages, maybe except JavaScript. And lastly, we will talk how to actually handle unhandled exceptions in your app. So let's switch to the code. Let's start from the very simple code that catch actually it's synchronous code, and how can you catch exceptions synchronous code. I will do it very fastly because it's a rather simple thing and basic stuff in Dart and Flutter. So you can see that if we have this kind of string that can cause the error, so the Dart provide you with some clue about what happens there. This is unhandled exceptions, and it said that it's exceptions integer division by 0. So it's very simple stuff. So what we can do to protect from this, to catch this exception, is to wrap it in the try catch. And if we run it in this case, and you can see that we catch the exception here. So that provides you with some different options how you can catch exceptions. You can use this catching of specific exception like pattern matching, right? So you can match different exceptions as in line 14 and 16, and and react accordingly. If exception is not so if it's some kind of unknown exception for you, so you didn't wait it, so you can just use this catch operator with exception and stack trace, and it's very easy to investigate later on what happens there. So you can see that in the third case we got actually the unknown exception, and you can see the stack trace, so it's easy to investigate. What is interesting here is that you can have finally block as in other languages, and this finally block will be called anyway after your happy pass or after any of your catch blocks. And even if you, for example, return from the catch block, even in this case, your finally block will be called. And even if you retrue, actually, right? Even if you retrue here, so yeah, you can see that this cleanup block was called before the rethrowing of the exceptions. So yeah, rethrowing is just a simple practice of the redirecting the exception to the upstream so you can handle it upstream if it's make more sense in this case. So this is about the synchronous exceptions, and I mean exceptions of that can be thrown from the synchronous code. Then what about the asynchronous code? It's much more interesting actually. So let's consider this example. So you have future and delayed future, and it will be actually it will call in 1 second it will call this kind of block of code, right? So let's see. So we can see that this try catch actually cannot catch this exception. So we can see this unhandled exception that was handled by Dart itself. So what's wrong with it? What's wrong is that this try catch block actually try to catch the exceptions in the moment when we try to schedule this callback, this future in our run loop. So, but it cannot code exceptions that happens in this block, because this block is scheduled in round loop and will be called later on. So what we can do here, we can wrap, for example, this exception, this piece of code in try catch, or we can do a bit differently. We can just put here await instruction, and then we force this callback be called here in this try catch block, so we can actually code this exception. You can see that, yeah. So now it's okay. This callback was called in this particular context, and we can catch this exception. But for example, if you want to have another thing here, for example, we want to have the chained future. So we want to have another block of the code that should be run after this feature. So what then? How can our try help in this case? Yeah, we can see that yes. So our try catch will actually can help you to catch all exceptions in all those all the chained callbacks, even yeah, if it's not that clear, but it's possible to catch it like this. Then what about how is it possible to avoid actually using try catch in this case? And yes, Dart allows us to do this. What we can do here is, let me copy this piece of code so it's much easier than change it. So this is how we can do this in more fancy, dot syntax way, some functional way, I would say. So we can just use this the same feature that will be called in 1 second, and then another feature that cause some exception, and we can catch this exception with this kind of syntax catch error. So let's start. Let's see. Yeah, it's the same as a try catch syntax, but it's maybe in some cases it's more easier to understand and follow. And we have the same the same kind of block of code that would be called after the catch or the happy pass, as in our try catch is a finally block actually. So it names when complete. So where we can do some cleanup. Yeah, and this is it. But if, for example, we make some error here in catch block, for example, there is another true, then of course we see that these exceptions cannot be catch here, because yeah, there is nothing that can catch this exception. So what we can do is make our code a bit more complex again. So we can put another catcher block here to catch exceptions that could be, thrown in the previous blocks. But it looks not nice. But still, yeah, still we can catch these exceptions. And of course, in this syntax, we do not do any pattern matching of the error, but it could be done. Code. Let me paste it here. Yeah, so you can do something like this. You can, in catch block, you can actually put some kind of testing of exception. If exception is 0 division by 0, then you do this, and if it's all other exceptions, you do that. But you see the code is, I think the code getting, so it works fine, yes, but it's getting some kind of messy. So a lot of things here. So that's why Dart actually code style encourage you to use try and catch of syntax in order to catch exceptions even in futures. And lastly, it's interesting to consider this kind of example. What if you have the synchronous code here and asynchronous code? If you use try catch, it works fine. But if you use this previous syntax that we just considered here, it will not work. So in this case, you should use actually try catch, or you should use some kind of synchronous feature. So let me provide you some example. So this is, for example, you have this kind of feature, some function, and if you want to use this catch syntax on this, 1 second. This is like this. So yeah, so if you want to use catch error for both synchronous and asynchronous exceptions, then you can use this kind of wrapping your code, all this code into the future sync. But it doesn't look, I think, very simple and easy to understand. So it's better to, return back to the syntax that I provided earlier. So this syntax much more clear and understandable. And lastly, so what about this example? So you usually use timers, right? And in many cases. So, and how can you actually catch exceptions in timers? So you see, we cannot catch exception in timer here, because timer again schedule this kind of block to our run loop, and this try catch already pass at the time when this block is actually scheduled. What you can do again, just to protect your timer function with additional try catch block, but yeah, you can do better actually. And then we switching to the presentation for a bit. So yeah, this is what we already talked about. This is try catch blocks in synchronous code, pattern matching, stack trace for investigation, and finally block that will be invoked anyway. Then exceptions in asynchronous code. So again, this is what we already done. So you need to use await keyword in order to be able to use try catch for asynchronous code. You can use catch error for the futures. Plus mixed synchronous and asynchronous exceptions, it's better to use try catch again. And then we start this run zone thing. So run zone, it's a bit different conception. So I just came up with this kind of slide. I don't know if it's clear or not, but zones actually in Dart, it's some kind of context zones that actually intercept all your callbacks that are being scheduled in this zone and wrap it to their own try catch blocks that helps to catch all the errors that could be thrown in this zone. And it helps you to handle all the unhandled exceptions in all these asynchronous callbacks and react to them accordingly. So let's switch to code in order to see how actually it works. So we can just consider the same example with timer, right? So as we talked before, you cannot catch exception in the timer in using the try catch. But what you can do is to wrap this to wrap your timer into the zone. So run zone guarded is a default way and the recommended way how you should use zones in Dart and Flutter. So you can just wrap your code into this instruction, and this is how you catch all the unhandled exceptions in your code. So this is like on error callback, I would say, right? And you can handle it. You can put it to Sentry or to Firebase, or I don't know, to do some cleanup if you need. So let's see how it works. Yeah, you see that no red thing here. We exception handled, and you can see here we create our new custom zone here. You can see, so each application has a root zone. So zone, it's some kind of underlined conception that presents anyway. And if you run your application without this runs on guarded, then you can see this root zone run. So because any code will be run in some zone. But in this case, you create your own custom zone under the hood, and all the exceptions that happens in this zone will be redirected to your this callback. And this is very cool. It can help you actually to handle a lot of exceptions that could be, squeezed in your code, because you can just forget or put some try catch in the timer, or if you have very complex asynchronous logic that do some, maybe retries of going to the server and using timers and do something crazy stuff. So yeah, this can help you to catch all the exceptions and redirect them to where they can be handled. Maybe a bit complex example here. It is rather. One second, I will find this stuff. Yeah, for instance, it's. I think it's a rather big one. So I just wanted to explain here that you can have zones and inside zones. So this kind of nesting can help you to, for example, have one zone for all your app, and the additional nested zones that can isolate your code. For example, code where you do this kind of business, some kind of asynchronous business logic, or another zone for some kind of third-party libraries that you cannot trust. And yeah, you can just split your code into these zones and handle exceptions for each zone independently. And here, if you run it, you can see that that different zones, you can have this kind of zone values. When you create zone, you can assign some zones values to zone. So each zone, it's like it's keeping some context, and you can write some. It's just a map. I don't know why I cannot go there. Yeah, here. Yeah, you see, this is just a map of the object and object. So you can use this map to keep some values there. And if, for example, you use you print some exceptions, you can put some clues about what kind of zone these exceptions was caught with. So plus you can maybe do some another. So actually these zones can help you to override some functions, like, for example, creation of timers or even print function. So print function can be customized for each zone, and it can help you to, more to use different printing for different zones. For some zones, you maybe don't want to print. You don't want to print though logs. And one of the, so we just consider these timers, that timer callbacks that zones can help with. And another another case where zones can help you with, it's streams actually. So if we, for example, consider this example, so let's start without any zones here. So this is like very simple app where that use streams. So you have some stream that by timer, it just emits some kind of integers, right, in this stream. And you have some listener that listen for the events. And let's see how it will work. So you see this 43, it's okay, but on 44, we have some unhandled exception here. So because our listener actually, when this integer is 44, it throws some exception, right? So of course, it's better to have this kind of try catch block here and catch all exceptions. And probably you should have another try catch block here to actually make this code safe. But what you can do, but if, for example, you forget to do this, right? So of course it's better, but you, for example, pretend that you forget to do this, then zone guarded again can help you to catch all the exceptions, both in your emitter and in your listener. So if you run this example, you will see, yeah, that we catch exceptions and your streaming continue running. So you can see that we actually catch both exceptions in listener that was thrown here, and we caught the exception from the stream here. Yeah, and stream goes further, and you know, everything is fine. So let's switch it here again. So yeah, zones can help you actually to isolate some code from like make it some kind of error-free and independent from another blocks of your code. So one of the examples where you can use it, for instance, if you on the backend, for example, if you have this kind of HTTP servers that serve each client with some with something functioning, so you can wrap actually each this kind of instance into their own zone, so they do not you know, the errors from one block of code will not, from one instance will not go to another. So zones can help you with this again. And last, almost last thing, right, is about the unhandled exceptions in Dart and Flutter. So let's again switch to the code, and in this, 1 second, I will switch to another. Yeah, actually, this is a Flutter application. So, and what I've done here, I just add this kind of exception in our build function. Yeah, I know this is really bad, but yeah, it could happen anyway, right? And what then in debug mode, you will see if you do this, you will see this kind of very fancy red screen with the error description, what actually happened in your Flutter framework when it tried to render your view, your screen, and you can see this error, right? But you actually, by default, you cannot do anything with this error, right? You cannot log it. You do nothing with this. So, but it's better, of course, to intercept these exceptions and at least you know, log it somewhere in your Firebase or Firebase or Sentry or whatever you want. So in order to do this, you need to just add this kind of lines of code. So you need to first initialize your widget binding in order to use the next function. And this Flutter error on error callback helps you to intercept all the errors that happens in your Flutter framework. So if you save this stuff, and you can see that we let's restart it. Yeah. Yeah, exception. Where is it? Oh, 1 second. Something. Yeah, one error exception. So we intercepted this exception, and we can log it somewhere in your in the system you prefer, where you want to log it. So then another bad thing that can happen with you if everything is work fine, yeah, but again this timer, right? In this timer you again throw exception, and then what? You can have this kind of verbose logs that helps you to understand that something was happened in one of the asynchronous callbacks, but you cannot log this error. You don't have ability to log this error. It's first thing. And the second,
Okay, sorry, Artem, you muted yourself. Artem? Artem? Artem, can you hear us? Okay. Let me think how we can catch his attention. Hello, Artem. Artem? Unfortunately, looks like last few minutes. Well, Artem, can you hear us? Hello? Hello, Artem, can you hear us? Okay. Could you please turn on your microphone?
Yeah, sorry for this. So how long I was talking without microphone? So my headphones was turned off, and yeah.
Yeah, so I think maybe you can 30 seconds, about 1 minute ago.
Sorry for this. So I was talking about this about this stuff about Flutter. How can you actually handle unhandled errors in Flutter? And I was talking about two ways of doing this. Maybe I just briefly return back to this code. So first of all, you can catch your errors in Flutter framework. So in the functions like build, like these kind of functions that produce this kind of red screen on your simulator. You can use this kind of Flutter on error callback and catch errors and log them to the Sentry or Firebase or whatever. And the second way of handling the unhandled exceptions in Flutter is using again our runs unguarded. So in this case, you wrap your run up into this runs unguarded function, and catch all the exceptions, all the asynchronous exceptions that comes from your code. So in this case, you can actually catch these kind of exceptions and again log them. Why it's important? It's because this kind of exceptions very hard to see in your logs. It's the first thing, and so because if you run, for example, if you debug on your simulator, then it's okay. You can see these kind of exceptions in your logs here in your IDE. But if you debug on the device, then those unhandled exceptions will not be shown on your logs. So you will not see anything. So you will see just timer 1 runs and that's it. So, and it's very hard to debug actually these kind of situations. So that's why it's better to wrap your code with this kind of runs on function and you know, explicitly print exceptions in your log and maybe send it to some of the logging systems. So I think this is what I was talking about probably before my microphone was off. Sorry for this again. And so here I just put it in another way. So this is your Flutter app, and the Flutter framework errors comes to this Flutter on error callback, and all other your code can handle you know, all asynchronous exceptions using runs on garbage. So, and I think run out of time, and the last slide is about the actually conceptually how you can use all those techniques. So it's only my view on this, so you can follow or cannot follow or may not follow this kind of conceptions and design. But usually your low-level libraries provide you with ability to catch the exceptions, say specific exceptions using try-catch blocks. And actually, there are a lot of specific exceptions in this low-level library. So in your service layer, probably you want to actually aggregate those specific exceptions and convert them to some kind of business exceptions that your business logic can understand better. For instance, you can have on a business logic that change view state in UUI. You maybe don't care about what exactly happens on your server, why it is unavailable, but you want to know that server is unavailable and that's it. And you want to, you know, warn users that something goes wrong. And probably you can just split your exceptions to two kind of types. One is something that cannot be revertible, or you know, you cannot actually somehow overcome this exception, and you can say users that, you know, oops, something wrong has happened. And the second type of exceptions can be that user can retry and have result finally. So, and this business exception, probably it's only two of them that can make sense for you. So on service layer, you can use, for example, try catch, and then later on between service and business logic, you can use multiple ways of doing this, or using feature catcher or just tuples or either or whatever you want. And between business logic and UI, I think you don't want to use any exceptions. You just update the state, so it should be easy. And the complex feature could be wrapped with the runs on guarded, as we talked about. And it will help you to catch all the exceptions that you missed in some place of your code. And probably that's it. So thank you very much, and sorry for that problem with my microphone. If you have any questions, and please, yeah, I would like to answer all of them. Thank you.
Thanks, Artem. I believe it's very useful presentation. At least I learned a few new things for myself. If you have any questions, please drop comments into that. It was interesting to have this exception during your talk. And I really encourage guys, please take a look into a survey, provide your feedback to survey form that was shared. It would really help us with organizing meetups and making it better. And looks like your presentation, Artem, everything was clear. There are no questions. Thanks for joining us. And thanks everyone as well. See you next time.
Bye-bye. Thank you.
Bye, Artem.
Bye-bye.